Good morning. My name is Felipe Almeida. I'm from Expertise Solutions in Brazil. We've been working on the past year on EFL bindings for C++, and we're starting to work now on JavaScript. And we're continuing the work on C++ through a stabilization phase that we're going to talk about too. Okay? Yeah. So this is our team. Felipe Almeida, it's me. We have Salio Senna that worked on C++ too. Carlos Carvalho and Lahi Lira worked on the MVC that we haven't pushed yet, but it's already ready. We're going to push on our branch so people can review it before. Vitor Souza worked on the documentation for ENA C++, but it's working on other projects inside Expertise Solutions. And we have a few interns too. Vinicius Oliveira have done a Google Summer of Code for Boost libraries, so we are working with him. Luciana Magno de Almeida is actually my sister. She's making university now and is learning C++. And we have João Gabriel, that's another intern too. So, on this, what's the status of our work today? On C++ binding, we are almost finished, and we're working on the stabilization phase. So we're seeing how to use the C++ binding, learning what to offer as an API by creating a media center application, which is unfortunate because that was planned before, but now we know that there is a media center application that's being written in Python. But we're working on the C++ media center application to get a feel of how to work on C++ in EFL. So that way we can improve the C++ API, including conveniences where it's possible, and where the stabilization has the weak points, where ABI or API might break in the future and things like that. That is going to help us to get a stabilized bindings for C++. We're also working on the JavaScript bindings, and it's still on a very early development. So we're mostly working on ENA data structures. We have finished the containers for JavaScript using the libv8, but we haven't really started on the generation part yet. Okay, so we are still on a very early stages. Talking about the C++ bindings, just a few key points on where we wanted to be on the C++ bindings, what were our goals. So we had a very good focus on performance for C++, because people is going to use C++ sometimes to actually not use C, so they actually expected to have performances as good as C performance in C++.
Have you actually measured?
Yeah, we're measuring it now with Expedite. We have ported Expedite for C++ using the C++ API. I'm going to talk a little about that.
Oh,
okay.
Yeah, but Expedite isn't really a great performance benchmark.
That's the only thing we have. I am going to talk about that
all the
later.
time on and graphic stuff. Really.
Yeah.
It's meant to benchmark, not API. It's meant to benchmark rendering code.
I mean, the load bindings have 100% of C performance in Expedite as well.
Yeah.
Yeah, well.
That's the only thing we have.
Yeah. We actually also had a great focus on modern API for C++, because we did not want to have another Qt API, okay, using APIs from C++ from 20 years ago. So we wanted people to work with C++ as they would work on a modern C++ syntax. So that's one of the reasons why we push for C++ 11 too, and actually to not depend on Boost libraries either. So that's a strong point also on the C++ bindings.
What about C++ 13?
There is C++ 14 actually. It's been released, and well, it's actually just a fix, mostly a bug fix standard.
Yeah,
but
is there anything useful in that could be
Yeah, there is mostly the constant expression part that is more evolved. It's more relaxed, but that's actually would not improve that much on the C++ binding because it would only be on template meta programming, and we actually have it working on the parts that we need. C++ 17, on the other hand, is going to be another thing because it's going to include concepts, so that it's going to be a little more complicated. But we have a few years yet. So using C++ 11 features, it actually has a lot of features new from C++ 03, and it actually changes a lot from how people is going to write code on C++ 11 now. And so our focus on performance, we have theme wrappers for C. Okay, so these theme wrappers are meant to not add no overhead, except a compile time overhead. That's not really possible to avoid on C++. So one thing we wrote the ENA C++ wrappers also as theme wrappers over the data structures on the ENA data structures. Okay. So for example, we have an ENA list pointer, and we can create a C++ object passing that ENA list. So what this happens is that the ENA list C++ object actually forwards first functions inside the ENA list pointer that it now owns. So actually size of list in here, it's the same size as size of ENA list pointer. It's actually just a wrapper for that pointer that has member functions that calls the C functions on ENA list. Okay, so they actually don't add any overhead on that part. Okay. We actually have support for allocators, for example, in the ENA list and array and etc. But if you're using the default, then the object doesn't change any size because the allocator is actually trivially constructible. So we use the empty base optimization to not add absolutely no size to the C++ ENA list. Okay. And you can actually get the ENA list back, okay, use the native handle. So we can see that this actually is just a wrapper for the ENA list pointer, okay. This is for an example of the wrapper for Canvas, EFL, okay. So it's actually also a wrapper for your pointer. The size of the canvas object is actually the size of the EO pointer too. Okay, so it's actually just, it's as it was using on EO pointer. The object is actually a standard layout compatible to an EO pointer. So what we do is that we have a lot of inline functions, and these inline functions do the EO do function to call the EO function in C. Okay, and it leaves for the EO to do the late binding of the function, so to do the lookup of the function. So we don't use virtual anywhere for the C++ bindings. This is, for example, I wanted to use a function that exists, but it got a bit longer, and then I just use full there. And a bars function. It's actually this is based on EVA's get XOI object from EVA's object. So we have, for example, a range list, which is a list that doesn't own the objects inside the list. So it's a range, and it's a range of EVA's objects. Okay, so you can see that it doesn't actually the 2CXX here. It actually creates the range list passing the ENA list pointer. It doesn't copy any objects inside the ENA list. It actually just starts interpreting that ENA list as being a range list for EVA's object, which means that this works because EVA's object is layout compatible to the EO pointer. Okay, so it just actually interprets the EO pointers as being EVA's objects, and then it can call functions inside the EVA's object and work as a list inside the range list. So that's the focus on performance that we had, so that we actually would not lose at all in overhead from C. It's actually, there is one point that we lose here. That's actually started discussing with tone, but we haven't really progressed on that idea yet. It's that EODO here in C++, you cannot do EODO for a lot of functions in C++ directly. The EODO is hidden inside the function that's generated, so you can't avoid the startup of the EODO and the end of the EODO for each function. On C, you can do EODO and call 3 or 4 functions on the same object, and that avoids a lot of overhead on the EODO. Okay, but this doesn't happen on C++. But actually, I'm thinking about a few things that might improve that performance too. Okay, but that's how much we focus on performance for C++. So we really don't want to lose it all from C on performance in C++. So whoever is actually more familiar to C++ would not have a reason not to use C++ if they wanted. There will not be, it's not performatic. It doesn't have enough performance for that. So there will not be a reason. Expedite C++, we're finishing the Expedite C++ code. It has comparable performances to C. It's actually a few tests go less than 1% difference, and 1%. Sometimes it's a little random. Sometimes C++ is fast, sometimes not.
Basically, when you are below 5%, you are on the same speed, because you are going to go above and below in the 5% range around the number.
Yeah. We have still a few cases where C++ in these tests are not according to the C performance, but we haven't really investigated that yet. We are going to investigate. It's probably because we have a very naive conversion to C++ on most tests. So for example, where one test in C uses a fixed size array, Savio changed it to a standard vector. So yeah, it's going to lose performance on that because it's going to do dynamic allocation. So we have to look at these points and to have a comparable performances on all tests. But
in those tests where Expedite uses fixed size arrays in C, those arrays are usually initialized during the beginning of the test, which means during the runtime there's no more initialization or anything like that, which means the vector shouldn't really slow it down. It should only add the minimal overhead, the millisecond or so at maximum, during the initialization, and then it should run with about the same speed.
Yeah, but in C++, in our cases, we have used pushback, and instead of using a index for the object. On the C test, it was a fixed size array and an index, and then it was just make attributions inside the fixed array.
I was talking about the pushback mostly happens on test init, not during the test run.
Yeah, well, we have to investigate the test to see why these problems are occurring. But they are probably very easy to fix. Okay, so it's actually allows us to test our optimizations to the Expedite. So if we're going to look for an optimization in C++, and then we can actually benchmark it again and compare if the optimization actually improves anything, because as we all know, early optimizations is the root of all evil. So we have to have a cases to test and see if the optimization is actually an optimization, not a pessimization, which is not uncommon to happen. And it allows us to catch performance regressions too, which is actually a good thing. But Expedite should have better tests to test actually maybe the performance of EO, for example, which actually it's not part of Expedite yet. On the modern API, let's show a few examples on what we mean by modern API. So let's see. It's not possible to see, right? So we have a simple Qt. Well, that's it's okay. So it's a Qt C++ application here, for example, and we want to compare that to a EFL application. And the main this is the header defining the main window class. We use this macro key object here, so that we use the mock compiler. Okay, we have to use that to have the signals working for Qt. And the main CPP here, we create the application, create the main window, show it, maximize it, and we have the main window here. Creates a new Q push button, sets its geometry, and sets the signal. And you can see that uses these macros here. Okay, and the random board to say that when the release signal for button here, you should execute the random button, which the member function random button here. It's actually you click, and if it's clicked, it sets the text for any button to click it, and then resets it back to unclicked. Okay, just the text on the button, and it's a very simple test. It only has a button in it. I'm not able to compile here because I don't have Qt installed in this notebook, but I have EFL, so I can run the EFL example. This is the C++03 version for Qt, and for C++11 we can actually use on Qt we can use lambda 2. So we can say that connect to the released key push button signal executes this lambda. Okay. So we capture the this of the main window for this lambda, and then if we can use the click the enemy button inside the lambda. Okay, so this is actually an improvement over the C++03 on Qt already, but it's still we still have to run mock inside the readers. Okay, so it's actually creates more work for the build system of the application because it requires us to run the mock on all headers we create that inherits classes from Qt. And as we will see, this is not true for EFL++ or use C++. And this actually means that I have to create a main window header. In C++, the C++ example, I don't even have to have a header. I can write everything in the C++ file and compile. So on the C++, this is the EFL implementation. I included the workaround.h there, which defines a few headers which are needed for compiling using EO interfaces today. And a few things that we need for elementary because of a few protected interfaces that were not hidden today. So we define those defines in workaround. We do include Avas HH. That means the Avas for C++ interfaces. And we are going to include the Elm box, and button widgets headers, which are auto-generated from.
Any reason why you didn't just include the master elementary.h3
Actually, the reason was that it's too big. So I think it's for C++, since C++ it's not very compile friendly. We usually avoid including more files than necessary. But I'm almost sure that we have elementary HH that includes everything.
I thought we had some master, but I have to check.
Yeah, we have to check, yeah.
I mean, for the purposes of examples, of showing people how to use it, how easy it is, probably should stick to the single header.
Yeah, probably, yeah. Yeah, we have those rules that automatically create the headers in EFL. And with that, we don't have that in elementary. We can just copy and paste there, and then we can create the elementary file through all the EO, that includes all the EO HH files. So it's actually, the elementary HH would be a header that includes all EO HH files. So it's very simple.
And in C, we're trying to avoid including those .eo.h stuff.
Yeah. So the main is the same as C. You use Elm main, and here we create the window. We are using this Elm Win U2 standard add for now, because it actually does more things than just instantiate the window. It creates the background as well. I think this should be maybe a constructing method for a window. I don't know. I have to talk to Daniel about it. And we're setting here the delete request to exit the Elm run rear. And then we just set the size for some value, random value there. And we set the visibility set to true, so the window appears. We are using this, create the Elm button, passing as a parent the window here. So EFL parent equals win, which says to button that I want to create this button without any parameters, but using window as a parent, okay? And then we set the text. Here we're still using, we're not allowed to using new pointer here, so we're talking with colleagues about adding a nullable property to parameters. So we can say that these parameters would be optional, and we could use as if it was new here, but we're using Elm text on the moment. And the same thing, we set the visibility to set to true, the position setting, size set, which would be the same as geometry setting in Qt. And then we just do the callback, click add, which actually adds a callback to a signal inside the C++ object. Okay, so as you can see, we can receive the clickable, which actually it's the button. Okay, we have something that here that would be that we're going to change. That the Elm button is going to inherit all the, is going to create new functions for callback, click add, where it would actually be here an Elm button. Because Elm button inherits from Eva's clickable interface with this event. But the problem is that since we are calling the function for callback click add inside the clickable interface, we are receiving here a clickable interface. But since Elm button, we are calling that on an object that's actually an Elm button, we have guaranteed that the object is actually an Elm button. So here we'll not need this downcast here, for example. Okay, so this is something that we're going to change. We've actually figured that out by using C++ API, and makes things more convenient, and doesn't add anything because it's actually just code, and you're going to instantiate one or the other. Okay, so and we can say Elm run for that to execute, and when the Elm exits here is executed, and we call back delete request add, and then we have when the person clicks exits on the window, then the Elm run stops running, everything goes out of scope, so everything is destroyed, okay, and all the references go to new, and then we have Elm shuts down and returns 0. So that's the whole EFL example. We don't even need a header here because we can just instantiate the objects directly in Elm main. Okay.
Is there any way you can drop, for example, the Ever's clickable interface clickable, for example, there? It just seems like stuff that is unneeded. It's already implied by the callback.
Yeah, actually, no. What happens here is that, yeah, I can't go too far. What happens, for example, I could actually just use the button inside inside here, I could say, for example, just say this and capture all the variables inside the scope, okay? And then I could just do this. It's actually, the callback actually receives 3 parameters. It's the IO description for the event, the object, what was called the event, and the void parameter for the parameter is a void star for the event, okay? And on this case here, we're ignoring all the parameters that are passed using standard bind, which is actually a higher order function that creates a function object from another function object. The first function object is the lambda itself, and the standard bind creates another function object that receives all the parameters and then calls the lambda without any parameter in this case, okay? And then we could actually do this, yeah, because we have a btn on this main scope here on Elm main. But the thing is that if this would receive the button directly, would not have to capture that from the main scope. So that actually would be easier too.
In C++ 14, you could also use auto argument, right?
Yeah, we have polymorphic lambdas in C++ 14, so you actually could use auto. But auto there, in this case, would actually be a Eva's clickable interface on this case. But how we are going to fix that, and we have a callback click that on Elm button as well, which actually is going to downcast for me directly to Elm button without Eva's clickable interface. So you would actually receive Elm button there. So you could actually use the parameter instead of have to capture that by reference on the main scope. Okay. It should actually even be faster using the parameter, because if you use the capture, you're actually going to have to use a pointer to the Elm button under the lambda, and in this case you have the EO pointer directly instead of a pointer to a pointer. Okay, but that's probably not even measurable. So
No, it's just the EFL one actually looks very complicated. There's a lot of casting, a lot of extra footwork in bits and pieces. No, but
Even the EO ref in the beginning, and like a lot of, I agree with Marcel.
yeah, well, the EORef is actually because we don't have a proper constructor in Elm window right now that should do that.
yeah, no,
Yeah.
No, but it's an example. In the EFL, EO parent, you have to write all of that, the parent of the button.
yeah, that was my next one.
Yeah.
The parent one. And by the way, the delete request, there is actually something simple. You can enable auto-del on a window.
Yeah, auto-del is a problem here because it's actually deletes the object inside the Elm run. So the problem is that this scope hasn't finished yet. So it's actually the object, it's destroyed under my feet.
It should be
Huh?
unref because it's referenced by its scope, correct?
Yeah, exactly.
It'll
But
be
Elm run
unref,
runs
that
before.
unref. And what you happen is you then enable the next thing, which is the Elm policy, which says that when my last window is deleted, I exit my main loop, which will then scope all out of that main window.
It will not work.
So if it's ref, it will not destroy the window.
We're
So
gonna fix
fix
the deletion to be like Gustavo suggested, which is just when you call EDevDay, it actually deleted, but it keeps the ref.
Yeah.
So
Yeah.
you can.
So it's alive in memory, so you
So
don't
now we
crash.
can't do that. Right now it doesn't work.
Yeah, right now it doesn't work.
Yeah, but still, I mean, we have Python, we have Lua, so it's not like it works for us in other scopes. As long as you keep
And
the
it works in
ref.
C.
Yeah, and see it, even with the O.
Yeah, but because I think that's because in Python you have a garbage collector, so you don't actually care you don't actually have this determinism on the destruction like you have in C++.
No, it works in C. You just
It
EO
works in
as a
C as
window,
well.
and then you unref it after the main loop, and it works.
Yeah, but it prints a lot of warnings. So yeah, it does.
Brilliant.
Anyhow, we talk in details. What
Yeah.
I'm trying to say is that we should type less.
yeah.
I mean, if we're in the business of saying, look, here's the Qt one, here's a modern C++ one, isn't this better? My answer is, dude, those lines are long. That is a lot of implicit weird stuff I would not know without knowing the inner workings and details of the bindings. I shouldn't, if you want to make it easy for people, I shouldn't have to learn and know these things. It should be easy for me. It should be dead stupidly simple.
Yeah, actually, I think that one problem is this constructor. Here, we have to have probably a class that has this constructor already.
I
Yeah.
understand what you've done there. I'm
And,
reading that line because you don't have a proper constructor wrapper. I'm ignoring it. That's fine.
Yeah.
The delete requesting, it is a good example of a very, very simple Lambda inline. It is a good example of that. But in the nicer way, the generic sense is autodel and then enable the policy of quick windows. Because that handles if I create 100 windows, it does it exactly as you expect. When the last window goes, my process exits.
Yeah.
It's the behavior that people really do want.
Yeah, but we need to fix autodel because it doesn't work right now.
And that's what I'm getting. If autodel's a problem, it's an issue we need to sit down and resolve somehow so it works as a programmer would logically expect it to work.
Yeah.
Regardless of references from the main loop and everything else, it should just magically work.
Yeah. Actually, I have here to talk with Don about your ref, your ref when he talked about your del.
So sort it out.
Yeah.
It's a good opportunity to do that.
Yeah.
Optimize examples, keep them as simple as possible.
Yeah.
Because then people go, oh, actually that's easy. Oh, that's not bad. Whereas opposed to if I have to know this clickable interface, clickable, like where on earth do I get that from? How would I have magically known that? That's what
that should be on documentation, but no, we don't have that.
Yeah. We want to make it simple.
But we're going to fix this on a clickable part, but there's another example that uses a class like it does in Qt. Because people sometimes going to actually create a class that has all the information, for example, like a controller class for the Y. So we have a class that has a Realm window, and that actually has the state for that window. For example, click it here. It's just a boolean that is on the Elm main here, and we'd actually you would use that the state inside a class that is instantiated in C++. So there's another example using that. And on this case here, we don't really need the clickable interface. But it's actually something that on the stabilization phase, we've seen that this should be fixed, and that we're going to change that to do for that, okay? But we should actually have the documentation on Ava's HH, for example, and in the elementary for C++ APIs too. So the person should actually look at callback clicked edge on Amy button, for example, and he should see what's the actual signature for the callback that's going to call. So she should be able.
If I have to look up documentation, that's one extra step for a programmer. If we can get it to work without needing any documentation, that's better.
Yeah, well, actually, if you generate the headers with the Doxygen-like syntax, mostly IDEs is going to show the signature for that and documentation directly. So the person could actually btn dot callback clicked edge open parenthesis, and then he should see what's the signature for the callback too. So he should be able to do that. I don't actually use IDE that does that, but people can do that.
But that's actually a good argument for having documentation in the EO files, then auto-generating documentation in the HH headers.
Yeah.
For EFL++, so it goes in.
Yeah, exactly.
Plus, it's not useful then for.
It's useful for C2.
Actually, it would go for C2, yeah, for C++ and C. For the others, yeah, I don't think that would work. But for C++, that would work very well for the IDEs. Okay. Yeah, the autodel should work here, but it doesn't work right now. So that's one thing that we have to work on.
That's probably something that needs to.
Yeah. The problem is also the problem with EODel and EONRef right now. So, and Eolian has actually changed a lot in the last month. We're actually, on the stabilization phase, we're actually running to actually get in parity virtualized with Eolian on the C++ bindings. So that's one thing that we're doing in stabilization phase.
You and Tom argue. Yell at each other, beat each other up with sticks. Tom should have been here earlier to be beaten up.
the same example using a class, for example, to actually control the Y elements. For example, in this, I actually use a standard bind capturing this, which is actually the main window. So I don't actually need to care about the parameters. So that's why we just ignore all the parameters and use the button that's actually inside the main window. Okay, and I use the clicker that state of the main window on the C++ side. Okay, so that's the same example running, and here we just create the main window and call run. Okay, so this is actually a bit easier to see. We use the list here for construction. We are using this Elm-Wing Util standard add, but now that should change to a proper constructor. And we are using that EFL yo parent attribution to win. And we actually have talked about that with Subransu, actually. He thought that doing that attribution to say that the parent was actually that one was a bit strange to him. But we thought that this was the only way that we can do to have a parameter for parents that's actually optional and doesn't add doesn't make the constructor ambiguous, okay? Because the constructor might actually receive an object, for example, on EO object. So if I pass the win directly as parameter, then he would not know if he's going to want the constructor with one parent or the constructor without any parent, calling the using that EO parent using the EO object. This is actually changing in Euler because constructors now there is not an overload on constructors, so this could actually change. This changed very recently, where we have actually constructing methods, and all the constructing methods have to be called. So there is no way to actually have two signatures for the same parameter. So this could actually be possible, where I would say that the parent is the last one parameter, for example. But that's not very descriptive either, because if I say just win to boot on constructor, that's not, I don't find that very descriptive to say that that's not a parent. So that's something that we have to discuss, especially with other C++ developers, where they find it more convenient to use. Okay, so that's one point now. But this was actually not possible because of the ambiguous problems that we had when Euler actually allowed us to have more than one constructor. Okay, so but since that has been dropped, that's actually possible now to not have an ambiguous constructor and passing the parent directly. Okay, what this does in C++ is actually parent is an object, a global object that doesn't have any state, and it has an overloaded attribution function, and that attribution function returns an expression unvalued of an expression of a type that's not used anywhere else. So that actually works because it can't be ambiguous, because we use a type that nobody else is going to use for passing the window parameter that is a parent. So that's how this works. On this example, any other problems?
No, I think we disabled that because we want the position set and size set. We split them because in EO it doesn't really matter, and we split. We can add geometries.
Well, I thought we had one, even in the original C++, original C. Right?
Min?
Yeah, in EO
Oh.
we only have such.
Okay.
We've only had diff before we split geometry size.
Yeah, I think it's moving.
Well, we just have 2 minutes here, so I'm going to.
This one we added a geometry set.
Yeah, I think we did, and then we moved it to the position and size set. I don't think it's related.
So, oh.
No, there is one in legacy, Tom.
Really?
Yeah. Yeah.
Yeah, told you.
Chris, we only added one.
If we had one in legacy, we'd probably have one in the.
No, no.
We don't have
Yeah,
one.
yeah.
I know it's a convenient thing because
Yeah, maybe we should.
sometimes you just do a resize, sometimes you just do a position, but also quite often you do a position and resize all together. And it just saves a line of code for a very common operation.
Yeah.
And it mirrors geometry. Yeah. It's nice and
Linear, we don't have geometry yet. We have size yet because it's easy to close in the same page.
it might be easy to in your interface thing, add a geometry, etc. Keep the size and position down.
So that's the image.
So the cat.
Yeah.
Good.
Now I know that there has to be a cat photo. That's actually my cat wanted to go to EFL Developer Day. So, this is the image, the viewer that Coleza and Tom had written in C, and I converted it to C++. So, yeah, and Lua and Python too. Yeah, and the code is actually very simple too. So first we create the window, as we do on the other one. We create the background, resize it, and create the image. And then we set the file set to the current window. This is actually creates a list of it's that vector of files, of name of files, okay? And we start from the last file to the first file, going through a reverse iterator. And use that on this image callback with the mouse down, where we just, if we reach the end of the files, we go back to the first one, and then set the image file to the current file.
While we are at the example, is there any way in modern C++, like C++ 11, to get some kind of more natural property setting syntax?
No, property syntax, no.
So there's no operator overload for dot or something like that?
For dots, no. No, we don't have. We actually could use objects as member objects that would have the operator attribution overloaded, but that would actually increase the size of the wrapper, and that would create an ABI problem, stability problem, because as new attribution, new properties would be added, we'd have a different size for wrappers, and that would create problems. So we don't have property syntax in C++ yet. Okay. So I'm going to skip the doesn't depend on boost thing. This was the things that we actually do not need boost for because we have that in C++ 11 now. If we were to use C++ 03, we might need to use boost because of these points of trap traits and standard error codes. Okay, so this is one example of in string share optimization that we use because of trap traits. Yeah, and JavaScript, we are using V8. We're very initial development of any data structures, and they are looking for an API that mimics what JavaScript developers would expect. And we have a few ideas on JavaScript bindings with the portability, because JavaScript can be used on lots of platforms. All platforms the EFL are going to work. And this would become a GUI for JavaScript, who doesn't have very good GUIs today for JavaScript. What?
Have you looked at the Elevate?
Yes. Yes.
And you're going to do it similar, completely different? What are your plans?
We're going to use the Node.js integration, like Elevate. Syntax-wise, we're going to go through with the EO API actually.
The Elevate API was at 2 levels. You did have the binding that was close to the C.
Yeah, but
And
Yeah.
then you have the wrapper on top of it.
Yeah.
but they
And
have
the
the
wrapper
hierarchy
was
stuff.
in JavaScript. So the JavaScript was using the C API from that.
Yeah.
But I mean, I'm talking about the declarative UI.
Yeah, but that's what you read the EU API today.
No, but will it
No,
be similar to
that's very different. It's very
No,
Yeah,
at the time, it was
just
a
like
JavaScript
you
code.
create like a JSON.
Yeah,
stuff.
but at the time, it was
Yeah,
JavaScript
but
on
I
top of
think you
EDevDay.
could do automatic declarative API using the API.
You can do it. I'm just asking if that's what
Yeah,
you're aiming
exactly.
for. If that's a good idea.
No, we are going for the EO API and have that mimic, for example, the asynchronous API for Node JavaScript. But we might next year work on a high level UI written in JavaScript to use the EO API.
For the Node.js thing, there's two elements there. There's some work in Elevate that
Yeah.
made it compatible with Node.js. You can load Node.js modules. There was other work that I know Gustavo did, which was to get Node.js to be able to integrate with the EFL main loop and vice versa.
Yeah.
Have you chased up that work to see what happened there? I think he submitted patches to the Node guys, and I don't know what happened to them after that.
Yeah, no, the loop integration I haven't looked at yet.
Okay, that's a really, really key thing.
Yeah, yeah.
Otherwise, there's no point talking about Node.js if you can't integrate.
I know, but we are going to do it.
Okay.
Yeah, then or we're going to write it ourselves or we're going to use the Gustavo patch, but that's going in. We're already using the libvh running directly as tests, for example. So we have tests for containers in JavaScript, and we run that as an application where we do make check, and it runs the JavaScript code as a executable today. And but we're going to use the Node JavaScript for the loop, and for the packaging we are going to use Node.js too. Okay, so we're going to look. We're not on this part yet for the integration on our tasks scheduled, but we're going to look at the Gustavo's patch too.
Okay.
And we're actually hoping to use Gustavo to review our code on JavaScript, yes, because he's actually very, very fond of.
Yeah. I mean, recycle as much of that work as possible. A lot would have already been done, if not all of it. I think it just may be that no one continued to push it into Node.js as
Or maybe
patches. It was
there,
kind of done
you know.
and then.
Yeah, we have to look at that. Yeah.
Yeah.
Okay. So we thought about an AP store for JavaScript and Lua too, because of the property of portability for JavaScript and Luas. So it's possible to have an app store where you are going to run applications on everywhere EFL is runs. And well, we hope more ideas can appear today. And here is a cat picture. Thank you.